Hello everyone and welcome back to our channel. In this video and the few upcoming videos, we'll be looking into the parts of the jet engine. Before going into the video, let's recap some known facts from our previous video.
Hello everyone, this is the heart of our jet engine. Now, in order to discuss its working, first let me show you an interesting element which is present in all our homes. Look over there. Yes guys, that's a fan. A normal household item, right? Now, come over here, I'll show you something. The fan right over there blows air forward on us so that we can feel the breeze flowing through our faces, right? Similar to that, there is a fan which is right here which blows the wind into these tubes. These tubes actually, here's a process is going on, a small controlled explosion which is called as a combustion, which also occurs in cars and bikes. Now, this combustion which is taking place here gains a lot of kinetic energy and the wind is passed into this turbine blade. Now, sorry guys, I can't actually show you the complete turbine blade because of this end nozzle, but there's a small section of it which you can see. Now, this turbine blade actually gets the kinetic energy through this combustion and then it rotates. Now, this rotation force helps the compressor to run. How you ask? Because the compressor and the turbine is connected on a single shaft as you see here. So, here's the interesting fact. The compressor, as it runs, it helps the turbine blade to run. And the turbine blade, in turn, due to this combustion, will help the compressor to run. You see there's a cycle going on. Compressor, combustor, turbine, and the turbine back to the compressor. A cyclic process. This is actually a small briefing, guys. If you really want to delve into this concept deeper, check our previous video where we have gone through the physics and all the elements of this jet engine. Now, for this video, come on, let's move into the compressor. Guys, this is the compressor blade. In this portion, if you see, a suction occurs due to the spinning of this compressor blade. Do you see these blades here? Yes, a suction is occurring here. This suction is then directed. Sorry guys, this is a failure design. A successful design is present inside. This is just kept for a visualization. Now, as you see, the wind here is then moving perpendicular to the main shaft and hits this stator plates. Here is actually the compression is occurring, guys. This is what makes it a compressor. Now, as you see, here a higher velocity wind comes and strikes this stator vanes and then it loses its kinetic energy and a small amount of pressure is built here which directs the wind into the combustors. Here you can see with the shield on. As you see, this is not actually a shield, guys. This is the manifold arm where the pressure is built and then the wind is directed into this combustor. Now, once again, as I said, the wind here is moving perpendicular to the main shaft, guys. Yes, if the wind is moving perpendicular to the main shaft, then it is called as a centrifugal compressor. Now, let me tell you about the classification of this compressor. There are basically two types of compressors. One is the static compressor and another one is the dynamic compressor. Now, if you see in a static compressor, the volume is, the energy is given discretely. So, it is not basically useful for this powerful jet engine. So why we move on to this dynamic compressor. In this dynamic compressor, there are basically three different types. One is the centrifugal compressor, and another one is the axial compressor, and another one is the hybrid compressor, which by the name you can find out it is a combination of centrifugal and the axial compressor. Now moving on, what is a centrifugal compressor? As I said earlier, if the wind or the compression is occurring perpendicular to the shaft, then it is a centrifugal compressor. Now, if the same compression is occurring parallel to the shaft, then it is called as an axial compressor, guys. Now, moving on, why did we use an centrifugal compressor instead of an axial compressor? That, my friends, will be explained to you by my friend Dwarakesh.
Hello again. We all know that the passengers as well as the military aircrafts are powered by gas turbine jet engines, which indeed has a compressor that compresses the incoming air before it enters into the combustion process. So, a compressor plays a prominent role on a gas turbine jet engine's performance. Centrifugal compressor. Why do you think it was named centrifugal compressor? Because the flow through the compressor is turned perpendicular to the axis of rotation. In the early 17th century, these compressors were used in pumps, blowers and fans as well. But in the year 1939, Frank Whittle, an English engineer, and Hans von Ohed, a German physicist, came together independently and invented the first gas turbine jet engine which had a centrifugal compressor. After World War II, these compressors were used in turbojets and turboshafts and as pumps in rocket engines. But nowadays, the turbojet and turboshafts use axial compressor. Axial compressor. Why opt for axial compressor? It is said that an average single-stage centrifugal compressor would increase the air pressure factor by 4, but it is not in the case of an axial compressor, because a single-stage axial compressor would only increase the air pressure factor by 1.2. But it is relatively possible to link several stages of an axial compressor, which would make it a multi-stage axial compressor. On weighing the centrifugal compressor and axial compressors pros and cons, we finally came to a conclusion that building a centrifugal compressor would be much more easier for us. But the centrifugal compressor had some limitations, which was the cross-sectional area of our jet engine got a bit wider, and we also found that it would gain an additional aircraft drag. But it was not in the case of an axial compressor, because the flow of air in an axial compressor will be parallel to the axis of its rotation, and the air will flow more freely and it would get pressurized easily. That's all for today's video. In the upcoming video, we'll be talking about the combustor part of our jet engine. If you liked our video, please like, share and subscribe to our channel and give us your valuable thoughts. Thank you.